morning to Dr. Hamid and my fellow friends. Today, my group and I would like to present about our project that involves GD&T for our subject Standard Product Precision. As I begin with our introduction, GD&T, short for Geometric Dimensioning and Tolerancing, is a system for defining and communicating design intent and engineering tolerances that helps engineers and manufacturers optimally control variations and manufacturing processes. Second, introduction about our project. I would like to begin with we build a shaft and a pulley that can be connected and must have a critical point. With a critical point and a fixed size, then the GD&T symbol should be in the drawing so that the drawing can be translated more accurately. As I move on to the next slide, which is our measurement tools that we use. The first one is vernier caliper, micrometer, vernier height gauge, dial indicator, basically to know the flatness of our project, and radius gauge, and lastly screw pitch gauge. And we also use a 90 degrees bevel edge square, basically to know the angle of our project, so that it can be 90 degrees as possible. And of course, we also use a ruler and a granite table as well. For the next slide, I would like to pass my friend Harid.
Okay, untuk slide yang nombor 6, measurement tool we use more advanced. Measurement yang kita orang gunakan adalah roughness measurement test untuk test permukaan projek itu sama ada rata atau tidak. Yang keduanya adalah bench centrist yang digunakan untuk melihat putaran shaft adakah bergoyang atau tidak. Kalau shaft tu bergoyang, maksudnya ada yang salah dah di shaft tu dan kemungkinan kulit akan dapat masuklah di dalam shaft itu. Okey, yang ketiganya adalah profile projector. Profile projector nak ukur sudut lah, sama ada shaft tu bengkok atau tidak. Kalau ada bengkok, samalah macam yang kedua tadi, dia akan kulit akan dapat masuk jugalah di dalam shaft itu. Okey, coordinate measurement test ataupun CMM nama pendeknya, untuk test ukuran yang lagi tepatlah projek itu. Okey, yang terakhir sekali flexible measurement test. Okey, slide seterusnya adalah inilah first part kita orang punya projek, iaitu shaft. Dan di sini kita orang menggunakan 6 simbol, iaitu depth of feature, run out, flatness, concentricity, circularity dan depth. Slide seterusnya adalah second part, iaitu pulley. Simbol yang kita orang gunakan adalah depth of feature, straightness, flatness, concentricity, circularity dan depth. Okey, itu saja.
GD&T we use and why. First is run out. Run out is a symbol that marks the part 360 degree. It is also a symbol to control the center point of the circle. It is to ensure that the part does not wobble when the project is installed. Then the project must be machined correctly and there's no hunchback in that area. Number 2 is straightness. We use this symbol to ensure that the part marked is not bent. If the part is bent, the pulley will not be able to enter that part properly. For this project, it has been established that straightness cannot exceed approximately 0.010 micron. Number 3 is circularity, to ensure that the marked part is exactly round and there is no oval in any part. If it will be uneven part, this will be a problem when in the installation process. Maybe the project cannot be fit or it's too tight. For circularity, it has been established that it cannot exceed or be less than 0.020 micron. Okay, number 4 is flatness. Flatness is a symbol to ensure that each part is flat and no part is hunched. Flatness for this project can be 0.030 micron. Number 5 is concentricity. The concentricity symbol is placed to indicate that a part of this project will be joined once. It will be remind the person who machined this part that the part marked with concentricity is very critical and must be made carefully so that the measurement cannot be less than or more than 0.15 micron. Number 6 is depth. It is used to indicate that the part has a hole with a certain depth. For this project, the specific depth is 2.50 mm and cannot be more or less than 0.015 micron. This is to ensure that the pin in the part can enter well without any destructive force the part. Discussion. Why is geometric tolerance necessary? When the designer orders sheet part, the size tolerance-based instruction will be as follows. This drawing may lead to a delivery of part like this. First, these parts are non-conforming or defective product. Number 2, no mention of parallelism in the drawing. Number 3, the fault lies with the tolerance instruction by the designer and not with the manufacturer. Okay, that's all from me now. I pass this slide to my friend Watson.
Okay, saya sambung. Description, why is geometric tolerance necessary? The drawing for the same part will be as follows using geometric tolerance. Here the geometric characteristic parallels and flatness used in addition to size. This can pivot out like as we saw about with size tolerance. 5 major advantages GD&T. Number 1 is saving money. GD&T enhances design accurate by following for incorporated tolerance that maximizes quality. Number 2 is showing dimensional and tolerance requirement, but explicitly static design requirement. Number 3 is assistant digital design method. Clear, consist GD&T data is readily adaptable to design digital design programs. Number 4 is offering uniformity and convenience. GD&T reduces guesswork and interpretation while issuing consistent geometries across design and manufacturing. Number 5 is forbidding accurate communication. GD&T enable designer, manufacturing and inspectors to communicate clearly with one another. In conclusion, GD&T is an efficient way to describe the dimension and tolerance of the design. It communicated the design purpose of component and the functional requirement in a clear and understandable manner. If you were to ensure that the part have been designed will fit perfectly for this means to server, then GD&T is the what we need. That's all from us. Itu saja dari kami. Kalau ada, kami memohon maaf jika ada kekurangan dan kesilapan dalam video ini. Itu saja. Sekian. Terima kasih. Thank you for watching.